Okay, let's finish some of these data discussions with a sort of look at some real pro figures from my paper from Nature Microbiology. And let's look at how some of these finalized figures actually look in these publications. So here's our first figure. And what you should realize immediately is that in big publications, it's not just the data that goes into the figures. It's also cartoons, it's illustrations. So you can see now why all the stuff that I'm teaching you can be used to enhance the publications that you create. And keep in mind that if you were to actually survey sort of like the area of this paper, half of the area is words and the other half of the area is figures. So the idea that like we train scientists how to write papers, but almost nowhere are there training programs on how to train scientists to make figures. It's kind of shocking because you should understand that 50% of what you publish, 50% of what you produce is essentially like artistic productions that go into these papers. So now you can understand why I'm sort of so passionate about this, because it's an area that does not get enough training. So let's actually look at what I've done here. And there's a couple of effects which you're going to recognize, which look really nice. So you can see that these eggs that I've made, they actually have a dropped shadow. Okay, it's very subtle, but they have a dropped shadow. And that's why the eggs sort of float on the top as if they're sitting there. Okay, and they also in the eggs have a little bit of shading. So all the techniques that I've been teaching you are going to be relevant when you're assembling figures. So let's look at this panel, this panel F here. Now you can see I'm showing you cropped gels. So I've done, if you go back, you watch the cropping lecture, I've cropped some of these gels, and you can see I've clearly marked within the gel where I cropped something out right here, and I cropped something out right here. So I've clearly marked that in case the reviewers or readers want to know what that is. I have actually put those gels in the back of this in the supplemental figures. So here's actually the original Western blot, which is in the supplemental, and you can see that these are the lanes that I cropped out. So I've clearly marked that, and you're going to have to mark that if you submit to high impact journals. But I also want to emphasize, so here's some data, here's some data, here's some data. But a lot of this figure, again, is not just the data. It's creative organization of how to clearly present what you're trying to say. So a lot of this figure is me constructing really nice lanes, really nice lane markers in Photoshop, really nice marking systems so that you can understand and interpret this experience provided that you have, or this experiment provided that you have the background capable of understanding it. Here are some beautiful serial dilutions. So again, these images that I had acquired were utterly almost perfect. And you have to do experiments many times to get the best images. You pick the best images, and then you can do some little contrast adjustments, and that's why these images look so beautiful. Now, you do have to be very careful in that all the images that you collect, they need to be representative of this. They need to be showing the same pattern. If you're doing microbiological data, or if you're doing Western blot data, or protein gel data, or agarose gel data, in general, it's accepted you produce at least, at the very minimum, triplicate images of each of these data sets independently, and it's expected that the pattern should match in all the triplicates. So here's some more Western blots. Again here, I'm showing you exactly precisely where something was cropped. So nobody's suspicious about that. Everybody knows there was a cropping here. I'm doing the edit stroke to put the extra sort of black little line around each of these images. And all, if you'll notice, if you look at these figures, all the type is precisely consistent. The type in here is the same as the type in here, is the same as the type in here. Okay, the font is the same as the font here, is the same as the font here, is the same as the font here. Okay, that is key such that you don't infringe upon the rule of importing elements from different universes. All these points, all these data look like they're coming from the same universe. And a part of that is because all these stroke thicknesses are pretty much the same. The lines in the graph are pretty much the same thickness. The font is always the same, and the font thickness actually mimics the thickness of, again, the stroke and the lines in the graphical data. All this sort of building the consistency is one reason why these images look so pleasing. And a final thing that I would point out is, as the first author on any paper, it's your responsibility to ensure that a consistent framework for figure construction has been followed throughout the whole paper. So there should be no figure that feels like it's out of place. It's coming from a different universe. And that is true in this paper, in a sense that if you look at all these figures, this figure, all the elements are constructed in a way where they look like they were derived from the same universe, okay? And this is a clear intention that you can create such that your papers are a lot more pleasing as a whole. So I would really encourage you, as you're beginning to go to the stage at which you're writing publications and you're assembling your data, assemble it within a framework such that everything is completely consistent. It's going to make your entire piece look extremely pleasing, and you're already going to set yourself off on the right foot with the reviewers who have to review it, and they ultimately make the decision of whether or not this gets accepted or not. So you don't want to do anything to upset them. And making things consistent and beautiful is a really good way to set the right tone with the reviewers.